Hi, my name is John.
And my name is Alice. You're watching Math Videos for Parents. We help you so that you can help your kids with math. And today we're talking about how to calculate the volume of composite prisms. And I think it's important first to just talk about what a composite prism is. So we have a really good example here, and that you can see this shape here, this 3D object. We don't have like one formula to handle it. But that's okay because it's two shapes put together. You can see if I had a cut right there, this top would be a rectangular prism. Let me put that permanently there. If I cut right here, if I kind of sliced it, then this top shape is a rectangular prism, and we can calculate that volume. And then this bottom shape is also a rectangular prism. So I'm just going to make two calculations to calculate the top and the bottom and add them up, and I'm going to have my volume. So you're basically just breaking it down to shapes you recognize and can calculate. So I'll start with the top one. And I'm going to say, okay, looking at this shape here, let me just outline it to make it really clear. I'm looking at this rectangular prism here. And I'm just going to say, okay, that volume, I'll call it for the top, is going to be 4 times 5. And then I need this length here, which is up here at 5. So I'm going to say, okay, 4 times 5 times 5. 5 times 5 is 25. 25 times 4 is 100. So I get 100 cubic inches. Now I'm going to do the bottom one. We're on a roll here. So I'm going to do this shape here. And I love this. It reminds me of like playing with Legos and blocks as a kid. So I'm going to say, okay, that's going to be height is 2 times 5 times 6. So 2 times 5 is 10. 10 times 6 is 60. So I get 60 inches, cubic inches. And now I'm just going to add them up because I've got the two shapes and I want the volume overall. So I'm going to say, okay, that's 160 cubic inches. That's the volume of my composite prism. John, what are your thoughts?
I completely followed what you did, and it makes complete sense. I'm just wondering if I split it up a different way, will I get the same answer? So I'm wondering, because I see a tall block in the back. Like I see this as its own, rectangular prism, and then this little smaller one, like a shoebox kind of, is put out in front of it. So I'm wondering if I would get the same answer if I drew the line this way and broke up the two prisms, I guess vertically instead of horizontally. So if I do that, I would first do the smaller prism, which appears to be 5 by 2 by 2. The height is 2, and then this is 2. So that would be 20 cubic inches. And again, we're doing cubic inches because it's volume, inch times inch times inch. And then if I look at the big part in the back, that has a height of 7. And then also I noticed that this part is 4, the part that extends out to the smaller part. And then 5 back here. So it's 4 by 7 by 5. And that is 140 cubic inches. And if I add them together, my total is 160 cubic inches, which appears to match yours.
Great. And, I had a thought when I was watching you do this. I think when you do these problems, you have to be really careful to grab the right dimension for the composite shape. And I think it can be easy to accidentally grab the wrong one, even if you understand the concept. So if you do it two ways, that's a good way to check your work. If you say, okay, let me cut it this way and calculate. Now let me cut this way and calculate. And if it doesn't match, that's fine. You know to check your work and kind of trace where the error is.
Exactly, because I see that you use the 6 for the bottom part, but I never use the 6. I use the 4 and the 2 that made up the 6. And then vice versa, I use the 7. You didn't. You used a 5 and a 2 when you broke yours up the other way. So I think it's a good thing to check your final answer to see if they jive, if you do it two different ways.
Excellent. All right, let's try another one.
Sounds good.
Okay, so now we're going to do a second one. This time I'm going to cut this way, kind of mix things up a bit. I've been inspired by the way John handled the last problem. So my first shape will be this rectangular prism here. I like to outline it for myself. It helps me ensure that I catch the right dimensions. So I'm going to say, okay, great. The area. I'm sorry, the volume.
We do use area though, right? We are multiplying like
that's
two together and then adding on the third dimension.
Yeah, that's actually a
so
great
it's not
point.
Totally wrong.
So, yeah, that's a really good point. I would use 13 here, which is this dimension there. And then I would use 10 feet here. So I'd say, okay, 13 by 10. And then I need this third dimension here. And I look and I see it's lurking down here. That's 4. So 10 times 4 is 40. 40 times 13 is going to give me 520. And that's just for the first rectangular prism. So now I'm going to do the second one. And again, I just like to outline to help me catch the right dimensions. Plus I like to use colors. So it's going to be 4 by 4 by 3. So that volume, 4 times 4 times 3, which is going to give me 48 cubic feet. And then I'm just going to add them up. So my overall volume for the whole solid is going to be 520 plus 48. And John, I'm sorry, I'm hogging the slide here.
No problem.
You're always so understanding. And that's 568 cubic feet. All right. John, do you want to do another method? We can make sure our answers match.
Sure. So I am going to take the same picture. Let me just make a copy for myself here. And I'm going to try it horizontally. So I prefer vertically like you did, but I'm going to challenge myself here and break it up this way instead. So if I break up the two shapes this way, I have to find the area of the top and the area of the bottom. So if I do the area of the bottom, I would have 13 by 4 by 4 for that bottom part.
That would be volume, right?
Yeah, volume. I meant volume. Sorry. Well, all these words are flying around. So 13 by 4.
Like you said, it's area times the third dimension.
Exactly. So there's area embedded in it. So that makes 208 cubic feet for the volume part. And the bottom. It's like a stick of butter. And then if you put something else on top of it that isn't quite as long but goes a little bit higher, we would then just want to find the volume of that solid as well. So for the top solid, I have 10 by 9. I want to be careful not to use the 13. 13 is the whole distance vertically. Alice did use that part, but so I have a 13 down here too. There's two 13s. Oh my gosh. I'm not using this 13. That I'm gonna break up into 9 and 4 because I'm looking at two different shapes. So for the top part, I have the 10, I have the 9. So because I'm using the 9, I would not use this 13. I don't want to confuse myself with the two different heights. And then the distance across also would be 4. This wasn't labeled, but we can assume it because it was labeled down here. So that part would be 10 times 9 times 4, which is 360 cubic feet. And then since they're composite, that means we can add those volumes together and get the total volume. And I also get 568 cubic feet as my volume.
Great. John, I really liked how you literally crossed out this dimension so that you didn't get confused. And I almost wonder if that would be like almost a good best practice. So when I was doing mine, I could look to say what dimension I wasn't going to use. And I didn't use this 9 because I made the cut this way. So I could have literally just crossed it out ahead of time and just reduced the chance of it accidentally working its way back in there.
Yeah, that's a good point. Something definitely to use next time.
Yeah. Excellent. Great. Well, wonderful. Thank you so much. And thank you, everyone, for watching. We're Math Videos for Parents. You can find us on Facebook and YouTube. If you find these videos helpful, please subscribe. It helps other people find us. And we're happy to take requests. If you have any math topics you're hoping we cover, just let us know. Have a great day.
We love new requests. Please send them to us.
Keep the math coming, everybody.